All right, hey there, algebra students. We're going to do a little bit of work to solve inequalities here. So one thing you got to remember when you're solving inequalities is that you use the same kind of strategies that you use when you solve equations, when we solve equations vertically. And so you can draw that line if you love to draw that line. To help you remember, you got to do the same thing to each side of the inequality. We're going to, in this case, we're going to divide both sides by 2 because this is 2 times x, and dividing by 2 undoes that 2. And so we'll be left with x on the left and 5 on the right. And instead of bringing down an equal sign, we're just going to bring down the inequality. And so we come up with this statement, x is less than or equal to 5, which should make some kind of sense because we started off with 2 times something is less than or equal to 10. And so that something must be less than or equal to 5. That's all we've figured out here. We have the additional twist that with inequalities, the powers that be love for you to be able to graph these things, so you make a little number line like you see with 5 in the middle. And that number line has to indicate that it says, hey, I think you should look at 5. And so we make a dot at 5 that's closed because it could be 5x is less than or equal to 5. And then we want to represent the fact that we're looking at all the numbers that are less than 5. And so we look to the left and we graph sort of just like this. We have this beautiful, wonderfully rendered number line graph that says, hey, look at all the numbers that are less than or equal to 5. So let's look at the next one here. Again, we're going to use the same strategies as we do when we solve equations. I see 3x minus 4. I'm going to get rid of the number that's furthest from x first. I'm going to add 4 to both sides. And so I get 3x is greater than 27. Then I'm going to take the additional step of dividing by 3. And so I'll get x is greater than 9. All right, so I need to make a little graph of this. So again, I'm going to make a number line. I'm going to start with 9 in the middle, add a couple numbers on each side. So 7, 8, 9, 10, 11. This one's a little bit different because it says strictly greater than. And so I'm going to make an open circle at 9 that says, hey, 9 is the limit, but 9 is not included. And I'm going to look at all the numbers that are big or bigger than 9. And so now I've got a graph that says, hey, look at all the numbers that are bigger than 9, but exclude 9 from consideration. That's not one that counts. So there's the basics. That's how inequalities are solved. Inequalities do have one kind of funny twist that we'll look at with this problem here. So I'm going to take away 4 because there's a positive 4. I'll get rid of that 4. I get negative 4x is greater than or equal to 88. Then I'll divide by negative 4. And here's where the twist comes in. I get x is, I'm going to write less than or equal to negative 22. And you might notice that I changed the direction of my inequality sign. And that might be a little bit weird to you. It's one of the rules that inequalities play by, and I can give you a brief explanation as to why that happens. So we can come up with this. I'm going to graph the following thing. I'm going to graph negative 2, negative 1, 0, 1, and 2. All right, and so if I look at my number line, it is really clear to me that 1 is less than 2. Look at it right there. 1 is less than 2. And so if I look at 1 is less than 2, that's a true statement. I'm going to take an action. I'm going to divide both sides by negative 1. We just divided by a negative 4 in our problem over here. And so I'm going to divide by a negative 1 in order to just test this out. And so when I divide by negative 1, 1 divided by negative 1, well, that is negative 1. 2 divided by negative 1 is negative 2. And I want to look at the relationship between negative 1 and negative 2. So I flipped across the 0, and when I flipped across the 0, the relationship changed. Negative 2 is actually less than, sorry, it's a little bit unclear. Negative 1 is actually greater than negative 2. And so when I flipped it across the 0, when I multiplied or divided by a negative, it actually changed the relationship. It created the opposite relationship. It was no longer 1 is less than 2, it became negative 1 is greater than negative 2. And that's one thing you can try to think about as to why when you divide by a negative, it changes the sign. Or you can just try to remember that if you are solving inequalities and you divide by a negative, you must flip the sign. Let's go ahead and make our graph here. Again, negative 22 is in the middle. We put a couple of numbers to the left and right of it. Because it could be equal to, we make a solid dot, and we're looking at all the numbers that are less than, so we shade to the left. Left is less than. All right, let's keep on plugging here. So I have 4x minus 3x is less than or equal to 9x plus 64. Let's take a couple of steps to try to solve this. So the first thing that I need to do is maybe combine some terms here. I see 4x minus 3x on the same side of the inequality, so that's going to give me 1x is less than or equal to 9x plus 64. And now I have 9x and 64 on the same side. That's numbers and variables on one side of the equation. I'm going to get rid of the variables. I'm going to take away 9x to make this a 0. If I do it to the right, I got to do it to the left. Take away 9x. And so I get negative 8x is less than or equal to 64. And so now I need to divide by negative 8, because when a number and a variable are right next to each other, you have to divide to undo it, because that's undoing multiplication. And so when I divide by negative 8, I get x and negative 8 are the numbers I'm going to be comparing. But when I do that division by a negative number, you got to recall that we need to flip that sign. So I flip the sign to reflect that, and I'll make my little graph here: negative 8, negative 9, negative 10. Put a couple numbers on this side: negative 6 and negative 7. So it could be equal to. I make a solid dot. We're looking at the numbers that are greater, so I go this direction. All right, hope that helped.